Hello. Today, I would like to clarify what is meant by capacitive region avoidance. First, I will share what the capacitive region is. Then, I will show what is meant by reverse recovery. Once we are clear on the capacitive region, I will show how the new UCC 25660 avoids it altogether. The capacitive region is when the LLC is operating below resonance. In this mode of operation, the LLC is no longer zero-voltage switching. Sometimes this mode of operation is also called zero-current switching, or simply hard switching. Regardless of what you call it, switching losses become much worse. The real problem with operating in the capacitive region is that the reverse recovery of the power switch body diode can lead to shoot-through and destroy the power stage. In the words of my friend Thumper, when operating in this mode,
You're gonna have a bad time.
first, let me remind you of how the LLC controller operates normally when in resonance. For zero-voltage switching, or ZVS, to occur, current must be flowing through the body diode of the switch. When the switch S1 is on, current flows from in the input voltage into the resonant tank. Now that S1 is closed, current automatically starts to flow through the body diode of S2. This is also referred to as the dead time, as both switches are off during this time, so if we turn on S2 now, the current will reverse. This is the time that the energy is transferred to the secondary side of the transformer, and so the cycle repeats. This is normal operation when operating in resonance. When operating in the capacitive region, there is insufficient dead time between switching S2 off and switching S1 on. Diodes take time to redistribute their internal charge to inhibit current flow. During this time, current is flowing backwards through the diode. This time is TRR. TRR is typically quite slow in power switches. If S1 is turned on while the body diode of S2 is in reverse recovery, for a brief moment, both switches will be conducting. This can damage the switch network. So how does the UCC 25660 avoid the capacitive region? There are two areas where the LLC can enter into the capacitive region. The first is at startup. When the controller first starts to switch, it is not in resonance and must try to get there quickly. The second is when the output power suddenly decreases. To quickly get into resonance while avoiding the capacitive region, the UCC 25660 extends the low-side gate drive after the first high-side pulse is terminated. It does this to ensure the current reverses to the very next high-side pulse is ZVS. By doing this, it only takes a few switching cycles to get into resonance, and only the very first pulse is hard switched. If the power to the load drops suddenly, there is a chance to enter the capacitive region. If you zoom in, you can see that the resonant current has reversed before the high-side pulse has terminated. The UCC 25660 adds zero current sense thresholds. If the current in the resonant tank hits the ZCS threshold, the gate drive is immediately terminated. This early termination scheme ensures the next switching cycle will be zero-voltage switched. This is how the new UCC 25660 can avoid entering into the capacitive region. I hope you found this informative. Thank you for watching, and please like and subscribe. Bye for now.